Hey everyone, in today's video we're going to take a look at this Sony STR7065. I took this as payment for doing some other little things you've seen on the channel in the past. Let's see if I got hosed or not. Now I've mentioned in the past on this channel that these receivers have kind of a special place in my heart. My buddy had one of these in high school and we used it for part of a larger stereo system we built. Anyways, this is the top of the line for the Sony series of receivers right here. This is the 7065. You can see that right there. Wow. This receiver came out in the early 1970s and it is rated at a whopping 60 watts per channel, which was pretty good for solid state in the early 70s. As you can see, this thing is in, well, really nice condition. You may recall, I believe it was a 7015 that we had on here last. The silk screen for all the controls and stuff, a lot of that was missing or in really bad shape. But this one here, everything looks really nice. Most everything is completely intact. This thing is very, very clean. Of course, the top cover here, really nice. I don't see any obvious big scratches here. And this is about all I know about this thing. Clean controls, October of 2010. So, there's a good chance this thing has not been powered on since the year 2010. Moving to the back here, the early 70s begins to show. We've got some pretty basic layouts here with your inputs or whatnot. And of course, my least favorite thing in the world is this style of speaker connector. Just screws. I really don't like these. But it's kind of interesting. You've got 3 sets. Not every receiver of this vintage had A, B, and C speakers. I don't think you can run all 3 at once. You have to pick 2 at a time or 1 at a time. The heatsink for the output transistors is on the back on this thing. I just move the antenna down. There you go. Made in Japan. Very nice. Well, since this was basically known to be working recently, I'm comfortable just plugging this right in. We are plugged in, and let's see what happens. Slight lights dim. Click. Does this thing use a relay? Oh, very interesting. We're getting some interesting activity out of the tuner here. I wonder if I can catch that. Look at these meters. They're moving around and the lights get dim and bright. So I think right there it's brighter. And there it went dim. So that's really weird that that's happening. I hear a noise. Don't know if that's going to come through. There's definitely like a little sizzling noise in there. You can see the tuning meter is not moving at all. So either we don't have an antenna hooked up or we've got problems. How about we move to the back of this thing? Let's see what's going on at the speaker outputs. So I am set to the A speakers. Let's see what we've got for DC offset at the back, if we've got anything at all. So on the right channel, we have 5960 millivolts. And at the left channel, we have 40 or whatever. A little bit unstable. I don't know if it should be moving around that much. So definitely got our work cut out for us. I wonder what... I smell a smell. I don't see smoke, but I am smelling a smell. Let's see what happens with the dim bulb. I just want to make sure we're not drawing excessive current. And we are not. This would be bright if we were drawing excessive current, and I would expect something about that bright given the power level of this receiver. So we're okay there. No bad shorts. But there's likely something going on in here that isn't quite right. I'm going to hook a little jumper up to the FM antenna just so we can get something going on out of the FM. Now, still nothing out of the tuning meter, but we are getting a stereo indicator, which is kind of nice. Do all the other indicators work? It would appear all the other indicators work, but how do you get this thing to turn on to mic? Well, I suppose I could hook up a speaker, see what happens. Just double check that we still have nothing bad for DC offset out of the outputs. Yep, that's gone down actually. And I think that was higher too. It's also gone down. Could be because we're on the dim bulb, but you know. Yeah, just to be clear, the smell I smell very well could be just a, like the light bulb is on and there's a bunch of dust and the dust is getting hot and making that smell. It's not quite a burning smell. It's a fairly distinct old electronics smell, but it's not a smell that I always get with stuff like this. Certainly not this strong. Okay, there's our speakers. Let's bring this back around. Let's bring the volume up. Oh, I'm not set to FM.
And wide up here.
There we go. So, tuner actually works quite nicely. Muting is working. Sorry, I think my arm was in the way for a lot of that. Our tuning is working excellent. I mean, muting works great. We're picking up all kinds of stations. And I don't normally pick up this many stations. And most importantly, it sounds good. So I guess at this point we'll hook up the phone and get everybody's favorite song going. You know, I never knew a buzzy little jazz tune could become such a polarizing thing in YouTube comments. Some of you just cannot stand this song, but everyone else, they love it. So I see no reason to use a different tune to test my equipment. So the balance control works great. We've got bass. That could be cleaned, it's a little noisy. That sounds good. Filter's all working. Loudness on. Reversing the mode works. Mono. No static in any of those. Well, overall, very good. Very, very good. And it sounds good, like I said. So that begs the question, what must we do to this thing? So this thing is working, but we found a few little things. We know our tuning meter is not working even though the radio works great, so that should be an easy fix, hopefully. And then our DC offset is not 0. You may have heard a little bit of static as I was attaching the speakers. That's that DC offset you're hearing. So we obviously need to get that as close to 0 as possible, and we'll probably need to check the bias on the amplifier. However, if it were really a problem, that would be bright, and I'd feel some heat on these heat sinks right here, and I don't feel any of that. I think we should get the cover off and take a look inside. Tell you what, there's some weird stuff happening in here. I mean, first thing I notice is, like, look how they've populated their boards. Like, they've got a lot of vertical resistors in here. That's not something you see all the time. At least you don't see it, like, as the default thing, you know? Like, most of the time they just lay flat. It's a lot more work to bend it that extra bit, you know? And then over here, I think this is the power amplifier board. Looks like we've got some oversized Christmas tree lamps on the power amp board. And they've got really nice screw terminals on these filter capacitors here. Quite nice. These are 6800 microfarad, 63 volt. Not that high, honestly. I'll bet you this thing could do well with an 8000 or a 10,000, but I don't know. I'm not the engineer who designed this thing. Yeah, lots of wires. Lots of wires going all over the place. Overall, very clean in here. Quite impressed. I would say I did not get hosed. This is a pretty nice example of one of these receivers. Alright, so I've got a few things to talk about. I had mentioned kind of a burning smell before. Not necessarily a burning smell, but just like a hot 1970s electronics smell. And that's coming from over here. Inside of here is some power supply components. Some of it is on the power amplifier board. There's a resistor and a transistor in there that both get really hot. And if you go on Audio Karma and look at stuff, you can see others have just completely toasted boards in this area. I'll try to move this loom a little bit, but see that one right there? That 5-watt 220? That's the one that gets super hot. And the transistor below with the heat sink also gets super hot. And it'll cook those ceramic capacitors up there. And yeah, that is where the smell is coming from. So, and then if you look, maybe I can show it. If you look straight down, it's tough to see. Camera's having a hard time focusing on it, but you can see that blue capacitor starting to bulge a little bit at the top. So definitely want to replace that. Big work needs to be done in the power supply there. It is inevitable that something bad will happen over there. It needs to be addressed while it's here. Next thing is something I noticed early on but didn't really have enough time to show. I'm going to turn the unit back on, and I have the speakers plugged in, and see if it does it. Yeah. On the right or left channel, there's some noises coming through. You hear that quiet static, and let me switch to aux. It's in the power amp because it doesn't change with the volume. Also, the volume knob is loose. You can see that board moving around. Oh, sorry. I'm not showing my microphone at the speaker. That's what you're hearing. Stuff like that is really tough to see in the scope sometimes because it's so quiet. Like, you know, let's measure the outputs here. Like, if that was something above, let's see, how many millivolts AC is that? Okay, it's 23 millivolts AC. Oh, and now it just went away. Look at that. Now it's 0. On the right, 0. And that noise in there is gone also. And yeah, oh, now it's back. So, oh, we've got a visitor. She doesn't come up that often anymore. Hey, you. Hey, what are you doing? I just fed you. Are you happy I just fed you? Hey, come here. Come here. You want scratches? Yeah, you do. Yes, you do. You're a good girl. But, I mean, like you saw, otherwise, the thing appears to be working pretty well. I mean, that's great sound out of the tuner. But yeah, I think I will start by loosening up this power amplifier board. And it's got some interesting fasteners on it. On the back, there's 2 of these little tiny push pin things. Will it focus? Yeah, you see that little black cap right there? There's a little pin going through. It's kind of like an automotive clip, but like smaller. And there's another one on the other side here. Those 2 at least need to come out. And then we should have fairly simple access to the power amplifier / power supply board. Let's unplug. Let's make sure that the filter capacitors are discharged. Get those little pins out. I'm pushing from inside. Okay, there we are. Okay, wow, it really was that simple. Okay, and the board appears to just lift right out. We've got some solder connections down low. What am I running into? I don't know. Yeah, look at that. Very nice. Those pins went into 2 little posts that are kind of screwed in here. I'm going to take out this back one so I've got a little bit less stuff in the way. And just one screw lifts right out. So put that back when we're done. And we'll definitely remember because we have no way of securing the board without it. Okay, much nicer. While I'm thinking of it, let's test our filter capacitors. Let's remove this ground thing right here. Really nice how they've got this actually. Not many things from this era have screw terminals like this, so I actually really like this. So that takes us out of circuit and allows us to put our tester right on the capacitor. That's a little bit more than 6,800 microfarads. I would suggest that we're potentially getting to be a little leaky here. And this one, 78, I mean, yeah. This one that's bulging though, I think we should get that out and see what that one looks like. See what this bulge-tastic cap is looking like. Huh, it actually measures quite good. We're going to replace it anyways. It's a 330 microfarad 25 volt. I've got these 330 50 volt capacitors right here. We'll just use that instead. Okay, yeah, now as I pull the board back and look around, it's becoming more obvious how much heat this thing has been seeing. And it's quite a bit. Oh, this one's a little close to a wire. Let's move that a little bit. Oh, come on. Yeah, much better. We'll just make our way up. Let's clean that up. Alrighty. Alright, we fixed it. No, we're just getting started. Why is it that I always choose to trim my fingernails right before I need to do stuff like this? They were nice and long before. It would have been really easy to get under those leads and bend them up, but no. Yeah, take a look in there. Let's move this out of your way. Look how brown that circuit board is from that resistor, and the heat goes up, so these capacitors and diodes also got extremely hot all the time, forever, the entire time. So I think I'll replace all of those just as preventative maintenance. You know, they weren't the ones getting super hot, but just the fact that they've spent that much time being that hot, not a good thing. Alright, we've got parts. First, we've got new lamps from Dave. dgwojo.com. We'll get into that later, but for now we've got some fancy new resistors that are higher wattage, bigger, and have nice long leads so we can kind of get them off the board. We have new bridge rectifier diodes, and then we've got new capacitors for that diode setup. Can't remember the technical term for that type of circuit, but it basically goes across the diode to help things. So I'm going to get started and I'm going to remove a few things. So you can see how dark everything is in this area. That's because of this resistor, basically, and this transistor too. We'll get to that. But heat is an enemy of semiconductors, and these diodes are semiconductors. So I want to replace them since they've been exposed to so much heat. And then these ceramic capacitors right here, I want to replace those as well. And this is our guy generating all this heat. We will get that replaced with something much bigger. This is a different 220 ohm resistor. It is 7 watt instead of 5 watt, and we can have this standing higher off the board. Then this guy is a 330 ohm. I've actually had this resistor for like 10 years, so we can throw that in there and make that happen. And then we'll kind of move all these wires out of the way, have them live further away from this area when we're all done here. Then these diodes I'm replacing, I think I'm using UF5405. Yes, 500 volt, 3 amp. That should be plenty to take care of that. Alright, without further ado, let's start removing stuff. Now I really messed up here with the parts that I chose. Did not check the dimensions on these WIMAs. they're going to be too big. Yeah, we'll need to extend the leads on the other two, I think. I got the lead spacing right, but I checked for that, but I did not think about how chunky these would be. Wow, I just noticed something else. Look at that resistor right there. The one just below the caps. That is cracked. Will it break if I do this? No, it's a little more sturdy. Oh, there we go. Yeah, that's not right. So we'll need to replace that one too. And probably the one below it, because everything in that area is so heat stressed. It just needs to be replaced after a lifetime of being heated so much. Alright, there's been a lot going on here. We have our diodes replaced with the UF5405s. Our ceramic capacitor is replaced. See, look at the color of the originals. I think that's supposed to be more of a green. Green is a little dark looking from all of the heat. Yeah, actually. The difference between those two, I think one of those was closer to the resistor than the others. We have replaced our 5 watt 220 ohm with a 7 watt 220 ohm. We've got it nice and far above the board. I haven't quite soldered it in just yet. And I wish this loom of wires wasn't in the way. It'd be a little bit easier to show you everything. I guess I can force it for a minute. Down here, what transistor is that? That is, I think this is Q802. I've replaced that with a KSC 2690, which is what the Audio Karma transistor cross-reference list says. Right above that is D807. I've got a 1N4004 in place of that. The old one, it just looked kind of gross. Again, in a high heat area its whole life. Probably not a bad idea to replace it. The thing that's missing from here right now is the big transistor Q801, and that was, I believe, this thing. It had the heat sink on it, and I've got a new transistor with the original heat sink on it, but it's not a KSC 2690, because Q802 is the same transistor. It's a 2SC 1124, the Sony 2SC 1124. I've got an MJE 15030. These are really hardy and stout, but the pinout is different, so you can see I did kind of a little cross thing here, and I put one of the original insulators off of one of the old resistors, put that over the collector pin, and switched these two essentially, because the way this one goes into the board, it's in a straight line. I was able to put the 2690 in there a lot easier, but this one you had to do a little cross-legged action there. So that just kind of pops in like so. And we can see this is basically connected to your collector, so you want to make sure nothing is touching that. So I bent my 330 out of the way. Then I've got a brand new 82 in there, also this blue one here. And then of course I replaced that broken resistor with a 1/2 watt replacement. And I think that's about all I'm doing for the power supply here. I'm going to get this soldered up, and we'll move on to the power amplifier section. And tell you what, there's some stuff to see. Yeah, one little thing I want you to note about this power supply section is, you see how it's like brown from here to here? That to me tells me that this trace itself was getting very hot. So what I've done on the back of the board for those guys is I basically kept the legs real long, or the leads, and I soldered them together like that. You can see how that's how the foil goes there. I figure I put them like that, then it's going to take a lot of stress off of the printed circuit board. Again, basically all I'm trying to do right now is just heat mitigation and making sure we replace components that have been subject to high amounts of heat. Alright, so we've done quite a lot just now. We've changed quite a few things. We've taken some guesses on some transistors, and we don't know exactly what's going to happen. So before we move on to the power amp, I've got the board kind of set in a way where I don't think it's going to short on anything. Let's just do the dim bulb thing real quick. I'm going to get the... Sorry, I was using the 200 watt bulb earlier for a future video that involves a power washer, believe it or not. Okay, let's see if we get bright bulb. We don't. It dims down fully. Okay, I like that. Now I want to get the schematic here. I want to see if I can see any voltages that I can kind of check for. Make sure we haven't completely botched everything. Well, the voltages don't quite match super closely what's on here, but we are on the dim bulb, so they will be lower. And I don't want to take it off until this is secure. And I don't know, that sounds quite good. I will say this though, there was once a very distinct odor, like a burning or hot 70s electronics odor from over here. And now it is a very modest, light, new electronics running hot odor. So I think I've done okay over here. I think I've made good substitutions. It is time to move on to the power amplifier section of this board here. I will start by showing you the filter capacitors have drained mostly, right? So now I can touch things. And we got these like weird Christmas tree lamp looking things here. I don't know what the heck these are. I pulled one of them off. And, you know, they've got this glue stuff right here, and everyone talks about how this glue is corrosive. Guess what, folks? We have the most clear example of that yet on the channel. Look at that resistor. Ain't nothing left. The glue was kind of sitting on the bottom part of that heat shrink shield or whatever. And, yeah. There's nothing left. Okay, well there's something left, but you can see the corrosion on that resistor. And then next door, the wire's in the way, I'll go move it. It's a similar situation. The glue kind of sat on that resistor, so that's going to be R721 and R771. I believe they are 4.7 ohm resistors. So yeah, if you've got one of these, definitely check underneath those. There's multiple other carbon comp resistors on here, you may have noticed. I'm going to check all of those, and if they're out of the 10% spec, because of the silver band means 10%, they will get replaced. All those electrolytic capacitors will get replaced. And then there's two varistors, like temperature sensing varistors in the bottom here. They're black with blue dots on them. They're down here. The YouTube channel Jordan Peer, he has a 4-part series on this receiver, and he goes pretty deep, shows a lot of detail, and one of the things he found going wrong on his was those varistors. He was like jumping DC a little bit. You could watch on his oscilloscope, the whole waveform was just moving up and down. So that was the cause of that. We're going to want to replace those, and the way you do that is you take two 1N4148 diodes and you put them in series. How do you do that? Well, you make them look like this. Then you take your soldering iron and you solder that together right there, your little twisty part. Snip off the little bow tie there, and then you've got two diodes soldered together in series. You just bend these leads down and drop it in your board. And just in case none of that was in view, this is what you're going for. I have not soldered this yet. Yeah, simple enough. Alright, just did a lot of work once again. So I also decided to replace our diff pairs right here with some KSA 992s. There's no DC offset adjustment on this amp. There's also no protection circuits, so you're going to want your diff pairs to be matched and reliable. So I did that. The old transistors are these funky looking rectangle with a diagonal things. Yeah, I got those. Got some audio grade caps for the 3.3 C701. Not sure what C706 does, but I just put an audio grade in there also. Same with 751, 756. Everything else was Nichicon PW. For C816 and 817, it's a 47 microfarad 63 volt, and I don't have very many 63 volt capacitors. I normally just buy them in 50 volt. But I had 200 microfarad 63 volts laying around. They've been laying around for a long time. I looked at the cap. It's basically just additional filtering coming off of your main filter caps, your big guys over here. So I figured bumping it up to 100 microfarad wouldn't make any difference at all. It'd be just fine. Like if we changed this 3.3 directly in the audio circuit to like a 4.7, that would definitely affect your sound signature of your amp. Then we got those corroded resistors replaced. All the carbon comps checked okay. I think that's about it. All the caps tested fine-ish. Some of them seemed to have higher ESR, and some of them, the capacitance was kind of way higher than it should have been. So I guess we can put our sleeves back on our Christmas lights here. Jeez, this amp board might be done. Let's throw it on the dim bulb, do a brief test, and see what we've got here. Turn the dim bulb on, and then see what happens. The same thing as before. I left my speaker connected too. That was silly. Probably shouldn't have done that.
This new artist
But
focusing on creating,
it does
and
work.
marketing their work.
That channel works, and yeah, you can hear there's some DC offset action going there, so we'll have to check that out, see if I did something wrong or if that's just a function of the dim bulb or something. We'll check that off the dim bulb.
Step out of the car, please.
Step out of the car, please. Sir, have you been drinking and driving? I think we're good. We're good enough to at least throw this back in the receiver, mount it properly, and put it on mains voltage and test for some voltages. See what's going on around here. For DC offset, we have... That's not cool. That's even more not cool. Why is that? I'll certainly have to figure that out. Real quick note on the DC offset. I was able to fix that, and that happened because I replaced the wrong two transistors. So you see these three right here? You got that one, that one, that one. These top two are your diff pair, Q702 and 703. This one down here, it's something that happens before the differential pair, which is not normal on these 70s amps. Normally it just goes straight into the diff pair, but we had this extra one as Q701/Q751 on the other side. So we had completely mismatched gain transistors right here to like, I think these guys measured at like 100 something, and these 992s, they measured at like 400 something. So massively mismatched gain, causing over a tenth of a volt DC offset, 100 millivolts on the speaker terminal. So again, no DC offset control on this receiver. It's very important that you have a matched pair for your differential pair to control your DC offset. All right, continuing our saga with the Sony here. This receiver is very noisy. I want to show you something. We're set to aux A speakers. I'm going to turn it on, and I'm going to show you. There's some noise coming from right in here. So I'll hold this over here. I'll turn this on. You can kind of hear that. And then over here, very loud, right? And I can control it with the volume knob, which means it's probably in the preamp. And this general area here is the preamp. This will go away after a few seconds now that the receiver is warmed up. I've been playing with this off camera, of course. I think it has something to do with an 11 volt AC tap off of the transformer. And that's this blue wire right here. Alright, I'm measuring all kinds of stuff right now. So we've got the multimeter measuring AC at that 11 volt tap off the transformer. And then this is our kilowatt. It's measuring how much current we're pulling. So I've got the volume up a little bit. I'll turn this on. And you hear all that noise? So keep note, we're at 10.3-ish volts and 0.34 amps. So what's going to happen in a minute is that's going to jump back up to about 11, and that noise is going to go away. So I'll edit it when it happens, but you know, just wait. I don't know what's going to happen with the kilowatt though. That I'm really curious to see. Okay, so there. It went away. Our AC voltage returns to 11.5, which is more along the lines of what we would want to see. And then our current draw actually goes up a little bit. I found something else a little interesting in here. Remember how I showed you the volume control is kind of loose? Well, you can remove it without removing the faceplate. You can stick a crescent wrench in there and kind of get this nut and washer out. But it was kind of interesting. Like, I would shake the volume knob, which is this centerpiece right here, and like I'd look inside. This is where it mounts. It mounts on these guys right here. I didn't see that moving at all, which is kind of interesting. But then when I did this more, I mean, look at that. This thing is loose on those crimps there, which is pretty interesting. So while this is out, we definitely need to clamp these back down. I've got some channel locks. I'll just kind of lightly squeeze it from here. On the outsides. And then I can come in with the small pliers and pinch down on all four. Is that better? Yeah. No more movement. And I was getting a lot of noise when I moved this around, or like if I touched this with my bare finger earlier. Very noisy. So, well, now that we've got this out and we've got excellent access to it, let's get our F5 and do the thing in here, huh? Okay, now that that's back together, I think I'll put it back in and see if anything different happens, because if you recall, with that Heath kit power amp preamp combo, we had some issues that just came down to dirty controls at the end of the day. Once I cleaned the controls, all those problems went away. So there's a good chance we're in a similar situation, but hopefully we're not. Okay, let's see if anything different happens. Nah, still got all the noise. Alright, I'm having a lot of trouble figuring out that weird noise. That drop I showed you in that secondary, the 11 volt, that's actually happening across literally the entire receiver. And the only way I've gotten it to not happen is disconnect the secondaries going to our bridge rectifier. So something coming off of our mains is making this happen. So it's just kind of a matter of isolating what exactly it is that's making that happen. I isolated the regulated power supply by removing, I think it was R840, which actually turned out to be out of spec. This is supposed to be 20 ohm, it was a 15 ohm, which is really weird. Normally resistors go up, not down. But anyways, I replaced it with I had a 22 that I felt comfortable with. I've got these like really, I have no idea where these came from, like 1 watt. I got them in like a pack on Amazon. Yeah, like this. There's probably nothing wrong with them, but like if I can use a more expensive resistor that I know is good from like Mauser, I'm gonna do it, right? So anyways, I'm taking a break. I'm doing the lights. So like I said, dgwojo.com, dgwojo.com. He gave me some lamps for this. He actually used one of these receivers to prototype these LED festoon style lamps. So those will go on the sides here, and to get those we got to remove the faceplate. But up here for the meters, this isn't too bad. So there's these metal tabs right here that you got to bend back on the top and bottom to get the assembly out. And then once it's like this, you can put your warm white LEDs in there, or replacement incandescents, whatever you want to do. And then put it back in, bend those tabs back. Very easy. So next is going to be removing the faceplate. This thing is fighting me so hard today. So we got the metal outside off, but these guys are real stuck on there. So let's try the heat gun. Let's see, is that hot? Yeah. Yep, there's that one. Jesus. Alright, well that was one of the more painful faceplate removals, that's for sure. Alright, but now we're inside. Now we can see the damage these original lamps have done. Check that out, right there. That's not very nice. So, yeah, how about we remove that screw there? Is that what that even is? What's going on here? Jeez. Oh, that's gross. Yeah, they didn't really think about serviceability in the future, did they? This is terrible. I guess you kind of pull that back or something. I don't know. There's your thing though. Yep, that's a burnt out bulb right there. Well, lucky for us, these new ones, we're not going to be so dependent on the shielding, because these guys, they transmit the light in only the direction we want, which is really nice. I think our new one should be quite happy in there. We'll make sure it's tilted the correct way. Pop around in there. And there you go. I think I'm going to leave that alone. I don't know what to do about that. Yeah, I think they really did think that this would just kind of last the life of the receiver, but here we are. Alright, let's take a quick look and see how that's working. Hey, that's pretty nice. It was not nearly that bright before. Very, very good. I like that. That looks nice. Now you may have noticed, but this receiver actually has an interesting function where the brightness of these bulbs changes with the function you're on. So like they'll get a little bit brighter when you're in FM. So we're in aux right now, and then phono. And you can see it changes ever so slightly, but it used to be a lot more obvious. That being said, though, the reason you don't see that as much is the LEDs, they're basically just looking for like a voltage, and they're gonna do their thing at a voltage, and it could be a plus or minus a few volts. Whereas an incandescent bulb, you're going to see every change in every volt very clearly. Also, I am actually able to see why our tuning meter is not working. And I've seen this before, and I had a suspicion early on. I'll try to show it. It's going to be very hard to show. I figured out how to do manual focus. It actually looks pretty good right here. And if I were to tap it, you can see it kind of moving around. Man, this camera's really nice. I am happy I purchased this camera. Yeah, look how zoomed in we were. I guess real quick, I just took off these little brace things to try and remove the glass because it is a little dusty. I had to get in with my flathead right up here because this rubber over time has really decided to become one with the sheet metal. And On the back of this is all the print. You're going to want to clean this so carefully because it's very likely going to want to come right off. But I did this so that I could get to this meter here and maybe convince it to be a certain way for me. I got to get in there and I got to bend that needle. So that's going to be painful and difficult to do. Alright, everything's about to fall apart here. So there were 2 screws. You could see them, the bottoms of them through here. They went in right there. I removed them. And now we can see, I thought this would be kind of like a sealed or encased meter like on a Marantz, but it does not appear to be. So that means, yeah, there she is. Okay, so it has not delaminated, but it is bent somehow. Yeah, see, we should be... See how that's kind of moving freely in a way? I can do that. This, not so much. So why is that? Look at that, right there. See that little dab of glue? Yabba dab of glue on the meter there? That's what's ruining everything. Because if you look at its friend, there is no dab of glue. That one. And it is free to move. But there is a dab of glue on this one. So what do we do about that? That's a great question. Okay, actually, I don't really know what that dab was, but look at this. It's almost as if we're not on that axle anymore that we should be on. I don't know, it's already effed. I guess we'll just take it apart even more, see what happens. I'm going to take this thing out. Alright, somehow, some way, I think I reattached that little tiny coil to the stuff using that vise, holding things in place. Now, I don't even know if my head is in the way, but now I take this off and I put this back over. Well, I did bend it slightly to do that, so now I should try to bend it back maybe, or not. I don't know. I don't know. If this works, it's just really lucky. Okay, I figured out the weird buzzing. So, you may recall, we looked at our 11 volt tap and we saw that it was like 10-ish, and that it would go back to what it's at now. I figured out the problem. It is a faulty power switch, which kind of makes sense at the end of the day, because we heard that noise, right? Now watch, see, it's doing the thing right now. I'll do this, and then it's back. Or it'll just do it at parts, I don't know. So now it's off. There's the bad. Still bad. But like, basically I can get everything to move and change predictably by messing with the power switch. So, I am not kidding when I say I think I've spent 8 hours looking for that. All freaking day. This is my Saturday, and I spent my entire Saturday chasing a bad power. I was removing the mains, removing the plus minus 50 from everywhere I could, just getting nowhere, figuring out nothing, and all it is a bad power switch. I'm going to remove this power switch and see if I can save it. If not, we'll be in a little bit of trouble. Just got a whole lot of arcing going on inside of that power switch. I tried spraying it with deoxit. That did not help. I figured it out when I completely disconnected the main secondary off of the transformer that goes into the bridge rectifier, but I still saw the bad activity out of the 11. So I figured, okay, it's got nothing to do with anything related to our filter capacitors. Our filter capacitors are probably fine, actually. But yeah, okay. I think I'll do that tomorrow. I need a drink. Well, I've got some excellent news here. I took apart the power switch, or removed it rather. 2 screws up here, get your amp board back out of the way, and then just kind of comes out. You got these 2 long wires. Look what they've done here. They have created their own kind of mechanical actuator thing to, you know, work this switch right here. But you know what this switch is? It's just a standard Omron snap action switch that you can buy brand new today. So when I saw that, I was absolutely thrilled, because I've got one of these laying around. It used to have the little metal lever coming over this button right here, but I cut it off. So now it's basically a drop-in replacement for this thing. If you're watching this hoping to fix your own, I think, I know, this is just an Omron V15, 15 amp switch, but they don't make that anymore. What you'll want to do is search Omron V15G. So yeah, there's your original part number, V-15G, and then make sure you look at the data sheet and get the one that doesn't have a little arm thing going over. You want just the open plunger there. So that's really cool, because I was thinking we were going to have some custom only Sony switch on here, but no, they got real creative. Looks like, yeah, this says Alps right here, so Alps made this, and it just works with your standard snap action switch, which is awesome. They use these today. I've used them at work on automation applications, like, you know, like door switches for machines. These things are perfect for that. I did try putting this together already, and there's a small change we're going to need to make. So you can see right here, this is our on position, this is our off position, and it's exactly the same. So what do we have to do? We have to modify our little actuator thing right here. So the way we'll do that is we'll just take some pliers and bend it. So I gave it a little bend there. I need to do better with my bend. That was not good. So that's on, and that's definitely off. Perfect. So there we go, new switch. Let's get these wires off and get them on the new switch. Okay, moment of truth. Let's see if we see our 11.8 or whatever, and definitely not like a 10 point something, and if we hear any more noise in that general area. Yeah. No hesitation, no questions asked. We're good. That was the problem. I am disappointed, very disappointed that it took me that long to figure that out. But I'm grateful that I did figure it out, and I won't forget that one. Let's check our main filter caps. How we doing there? Yeah, it's still lower on that side than it is the other side. So yeah, 53.4, 53.5 versus 52.9. So I did order new filter capacitors with the screw terminals that should be complete drop-in replacements, and I will replace them because, you know, I ordered them, and we'll just see if those numbers are different once they come in. But I'm a happy camper now. Let's see if we have sound. Still a little bit of hissing in the speakers, but you know, whatever, it's nothing terrible. I think this calls for a celebration. Yeah, that's right. And I do have to say, I think this receiver sounds really, really good. And I probably wouldn't have gone through so much trouble so far if I wasn't so impressed by how it sounds when I first got sound going through it. So yeah, I'm getting to be kind of proud of this thing. I'll probably hold on to this for a long time because they're not really worth anything. Alright, so what's left? We've got to clean up all this junk, you know, gross, and then put it all back together. I'm not going to touch the pre. I think the preamp is just fine. Power amp, we're all good over there. Tuner is working well enough for me, at least. We need to set the bias. We need to change the filter caps, and we gotta go do power testing and look at the waveforms on the oscilloscope and make sure nothing real bad is happening. There was one other thing Jordan Peer found on his that we might need to do on ours as well, and I'll explain that in a minute. Or maybe I'll never explain it. Maybe I'll just make you go watch his videos. No, it had to do with the RCA jacks in the back. Apparently they're kind of press fit, so the ground connection, those two metals together can start oxidizing and you'll get some resistance instead of a clean ground connection on the case of the RCA connector. So you gotta just take that panel off and do a little dab of solder on each one and call it good. I'll probably do that off camera just to be super sure. But yeah, no, this is great. And this is gonna look absolutely killer with these warm white LEDs. Normally I don't like warm white LEDs. I really don't like them on a Marantz. But on this, I think this is gonna be pretty good. All right, bias / idle current adjustment on this thing. Very easy. Your adjustment pots are right there and right there. What we're gonna be doing is we're gonna be measuring across. On this side, we have a red wire and a violet wire. They go to some posts right there. We just measure across that. And then on this side, we've got a white with a violet stripe and a white with a red stripe. We're going to measure across those two pins. Set your voltmeter to DC. Use your probe of choice. Okay. We are very low right now because I turned them all the way down when I was going down some ill-informed paths earlier. Of course, I put my probes where I need to have my screw, so service manual says 50 millivolts. I think what I'm going to do is I'm going to call it 40, because 50 just seems a little high for my liking. So there's your 40. It said 50, but I'm doing 40. And then let's go over to this side. Again, nice and low. Let's crank it up. And we'll start at 40. I'm going to listen for a few minutes and then I'll come back and double check that because we are, our heatsink is cool because we've been operating at no bias for a little while. So I'll come back and check that in a minute. Alrighty, the new filter capacitors are here. These are Chemets made in the EU. 10,000 microfarads versus the 6,800 microfarad ones that are in here stock, and they are screw terminal. I specifically bought them because they're screw terminal, because, well, we've got screw terminals in the Sony here, and that's awesome. But there is one small caveat to that, and I'll show that to you. These new filter capacitors did not come with screws, so I had to run to the hardware store and buy screws, and that really makes me angry. Certainly more angry than what I'm trying to show you here is M5 by 0.8 screws are too big for whatever's going on here. These must be M4 or something. Something just one step down. So yeah, we need to drill these out. I think what I'll do first is I'll just remove everything, get the caps out entirely, put down a paper towel, and then I'll drill stuff out, and hopefully we can keep the mess to a minimum. I'm using a 13/64 drill bit here. Alright, and then last thing is, since these are not quite the same diameter, we need to do something about that. So I was going to try wrapping it in electrical tape, but it's a little bit bigger of a gap than I wanted. I might have something laying around. I think the silicone rubber stuff that I have will work. This came from when I used to work at a place that manufactures heaters. Let's see if it works. Last time I used this, I believe it was for a Marantz 1040 amplifier I sold, and geez, that would have been a really long time ago. To about right there. Let's see, will this do the thing for us? Yeah, that's not terrible. I think I can allow that. Now let's just make sure we're oriented correctly. Now the only thing I should have done was take note of how long that first one was, so I don't have to do that measurement twice. Oh well. Oh, actually, I can just use this piece, and then I know what my measurement is. There we are. Tight enough. This is not a car. It'll be just fine. Alright, there you have it. It looks okay. They're a little bit smaller than the others. Smaller looking than I thought they would. And, you know, that foam is only doing so much, but, like, you know, when I try to yank it out, it's holding on pretty good. So, not terribly worried. And I made sure I got the lead spacing the same or very similar to the old ones here, so that this would all line up. I did have to kind of twist them out a little bit, because these are shorter as well, so you got that extra length. You want to kind of, whatever. So, okay. Now I am curious to see, did I get it right? Yep, positive, positive. What new voltages do we have? Are they the same voltages? I'm very curious. So let's see what happens here. Oh. The radio was on, and there's no antenna, so that was the muting circuit kind of figuring itself out. But anyways, let's set her to DC. There's the negative, and then on the positive we've got 52.9 and the negative 53.6, exactly like it was before. So maybe the filter capacitors were just fine. Maybe there's nothing wrong with them. And then do we have that ripple? Yep, and is it half as big back here like it used to be? Yes, it's the same. And there's still some noise out of the speakers that nothing happening. So I don't know. Probably should have done a power test or something to show power figures before and after, but I don't think that's really going to be completely necessary, honestly. But speaking of which, electrically, I think we're okay here. Everything sounds good to me. I could go through and restore the preamp, recap the tuner. I see those orange capacitors in there that are known to get leaky. I see some tantalums in there, but you know, we're at an hour in the current edit as it sits, so I'm feeling pretty okay about this. I'm more excited to just start listening to it, you know. So I think we should get this on the scope. Let's look at the waveforms, see if everything looks okay, everything's behaving properly, and that'll be it for this receiver. Alright, here we are at the scope. I've got a 1 kilohertz sine wave going through the receiver right now. First thing I wanted to check is are the inputs equal? That Jordan Peer video I alluded to earlier, what he found was that the press fit RCA jacks in the back, the press fit, the two pieces, you can get oxidation between those two pieces, which can create a resistance and create uneven inputs, because he was going to huge lengths to check like his volume control, his balance control, found that it was all okay, was checking all the amps and stuff, and it turned out it was right at the RCA jack where he was getting unequal stuff. And you know, this balance knob is, well, it's not really a knob, you can see you just kind of go like this. It's a really weird design, never seen anything like it, but I want to show you. Let's bring the volume up. So here we are at, like, you know, half volume, 5 volts AC. We're tracking quite close. And here's the balance knob. Like you can see, like there's a big amount of movement right here where nothing happens. So I'm happy to see that, because now I don't really have to guess so much about whether my balance is set correctly or not. So you can see one goes down, the other one goes down. Those are the two different channels on the scope. I've got each channel, left channel and right channel. So that's working. So I think at this point we gotta turn down the volts per division and see how much power we're making. We're gonna look at that number once we see clipping on the oscilloscope. And there's the clipping, those flat lines right there. So if we back off until we're not clipping, interesting. We clip on the negative end of the sine wave a lot more than the top, which is kind of interesting. Alright, so right there, 25 volts AC. Let's throw that into the Ohm's law calculator and see what happens. So we'll call that 25.2 into 8 ohms is, guess what, 79 watts per channel. That's way more than 60. Tell you what, I'm genuinely curious to see, like, you know, would those lower spec filter capacitors change that number? I don't know. But yeah, I mean, this thing is performing well within its rated stuff. You know, a little interesting that we get the clipping on the negative before the positive, and that's something you can balance on a Marantz 2230, for example. There's actually an adjustment for the clipping, but that's a completely different amplifier design. That's capacitor coupled versus direct coupled. We can change the frequency to be, what does it do at 10,000? And a lot of you pointed out we can't rely on this for the power rating, because the voltage it gives is going to be a little bit less. Let's turn that up a little bit. Yeah, it clips at about where the volume was before. Now let's try something low, like 100 hertz. See what it does with that. We'll need to go way down with that. Yep, there we go. And at 100 hertz, yeah, we clip at about that, you know, 2:30, 3 o'clock number right there. How about 100 hertz square wave? That's a little goofy looking. Probably shouldn't look like that, but I don't know how reliable this thing is as a square wave generator. Back to 1,000. Yeah, that's a little ugly. But, you know, we're hitting it pretty hard when we do that. That could be better. That could definitely be better. But I'm not advanced enough to understand how you would go about making that better. Anyways, back to sine wave. And we are still clipping at about that 25. Oh, now we're a little bit higher, 25.4. Yeah, at this point, I think we're good. I like the way this thing sounds. Let's see how we're doing with heat back here. Yep, that heat sink is warm, but it's not burning hot. The regulated power supply. It is aromatic, but it's always going to be because that's how it is back there. That's just the way they designed it. Not much you can do. Well, this one certainly threw me for a few loops. This power switch was a real fun thing to figure out. That tuning meter, it doesn't quite work still, but I did manage to somehow fix it. I don't know how I got that wire soldered on there, but that was crazy. If you put a DC voltage to it, you can get it to move side to side. I tried it with my power supply, but I'm not too worried about it. This is just going to be for me. But yeah. I really like this thing. I think it looks really, really cool. The LED lights really bring this thing alive. The incandescents are just not bright enough. This is one of those receivers where I think you've got to do the LED conversion. I thought this was just going to be a quick turn it on, it works, clean the controls again, it's working okay video, but that is not what happened. There was a lot to this thing, and there's probably still a lot more to do if I wanted to dive deeper later on. And maybe that'll be a future video. I don't know. We'll see how this one does. But if I were to do anything else, I would really look closely at the tuner and the preamplifier and see, you know, what's in there that's wrong. Right now, I can't really tell too much. This thing sounds good to me, and I'm enjoying listening to it. So, there you go. That's it. Thank you so much for watching. I hope you enjoyed this video, and I will see you in the next one.